Welcome to this demonstration of using Autodesk Simulation CFD. Autodesk is focused on providing digital prototyping solutions for moving beyond the 3D design to accurately solve real critical challenges before making physical prototypes for testing. We'll focus our attention on the choke valve that you see here. While this design has been modeled in Inventor, users have the same ability to launch designs to the CFD environment from SOLIDWORKS, ProEngineer, or Creo. On the inside of the valve, you'll notice a cage that has been inserted for a few reasons. This will make the flow more symmetric, it increases frequency levels, and directs bubbles due to cavitation away from the walls of the valve body. In the end, it will extend the life of the product and reduce maintenance costs. As you can see, we have several cage designs to choose from. Our goal is to find out which one is going to provide the lowest pressure drop and remain below a velocity of 200 inches per second using a volume flow rate of 50 gallons per minute. Before launching the design to run the analysis, we have extruded caps on the inlet and outlet. The enclosed volume on the inside will automatically be generated in Simulation CFD, saving the time it would normally take to draw the water manually in 3D. Let's begin the analysis. Setting up the design scenario has been made easy by listing the steps above the graphics window. Select the material, boundary conditions, mesh, and finally calculate the results. Let's get started with the material. This is done simply by selecting the component and specify the type. There are several options besides solids and fluid. Also choose items such as fans, centrifugal pumps, heat sinks, PC boards, and more. This enables designers to specify the details of the part or choose a supplier rather than the time-consuming process of modeling the detailed features. And of course, we'll also specify the fluid moving through the cavity. As we mentioned earlier, that has automatically been created by having an enclosed model from the CAD system. There are a wide variety of fluids to choose from, and they are fully customizable for Newtonian, non-Newtonian, incompressible, as well as compressible solutions. The boundary conditions that we are about to apply are the real-world surroundings that will help us to accurately determine the performance of the choke valve and help us to reach our design goals. Users can simply select the location where the fluid is entering and leaving the valve, and specify the flow characteristics in many different ways, depending on what the engineer knows. This includes items such as volume flow rate, thermal characteristics, humidity, and even electrical current or voltage can be applied to simulate heat generation. In this case, we need a volume flow rate of 50 gallons per minute and a gauge pressure of 0 for the other end. That's enough information to gain the results we need for the velocity and pressure drop. Next is the mesh, which applies the elements that match the CAD geometry. Autodesk Simulation CFD will automatically recognize areas of high flow gradients and increase mesh density for high-fidelity results using adaptive meshing techniques. This eliminates the task of adding them manually in areas of concern. Now that the study has been prepared, it's time to solve. There are several options available for calculation, such as steady state for the final flow result, or transient to view the change in flow or heat transfer over a period of time. Thermal solutions include options for natural or forced convection, conduction in the solid, as well as solar heating and radiation effects. For our purposes, we can leave these options unchecked. Cavitation can also be used to provide more accurate results in cases where the fluid reaches vapor pressure. This improves the accuracy of forces computed on the walls of the valve body. Before running the study, you'll notice that this baseline scenario has been cloned 5 times for various designs of the cage on the inside. They can then be scheduled to run at the same time or at a later date and time using the Solver Manager. Autodesk Simulation Flex offers the option to either solve using your local hardware, which is unlimited, or to the cloud, which frees local resources for working on other projects during work hours. Let's take a look at the solution. We ran all 6 of the design scenarios ahead of time so we can proceed right to the results. Here you can see a global pressure plot displaying the outer surface of the fluid volume. You can also see the mesh elements that were automatically generated and match the CAD geometry nicely. We'll start by taking a look at the internal flow. These traces will help us in a couple ways in our valve design. First, we gain a good understanding of the flow pattern inside the body and through the cage. It can be animated and even saved as an AVI for customers and coworkers to review. The added color to each trajectory displays the result type of your choice, such as pressure or velocity. Secondly, we can use these traces to determine areas of possible erosion. Add the physical properties, and then view the results. There's no need to recalculate the scenario to view different sized particles that may be in the fluid flow. There are also section planes for viewing the internal pressure and velocity profile. The plots update dynamically as they are dragged on the graphics view. And they are capable of displaying several types of results, such as pressure, velocity, temperature, density, shear rate, and much more. There are a few ways to view the results from each plot. The dynamic probe enables users the ability to see the values on the cursor quickly and easily in the bottom left-hand corner. Also take advantage of plotting the results along a selected path. Once a series of points has been specified, observe several types of results, such as the pressure and velocity that we're interested in. There is even a checkbox for reusing the same path to compare the results amongst other designs in the decision center. Let's take a closer look at the velocity profile. There are several settings available for all plots, such as showing the direction of the flow using vectors. This will help us to determine locations of vortices and dead zones in the cavity. Next, we have isoplots, which is a great way to isolate results based on a value. We may only be interested in a specified pressure or velocity in the design. This again will generate a surface that can be dynamically dragged or enter in a critical value. Our intent in this design may be to keep the velocity below a value of 50 inches per second. This is a great way to visualize areas that are outside our requirement. Now, the real power behind Autodesk Simulation CFD is the decision center. The ability to compare results between design variations is critical to discovering the best design possible. Under the graphics view, there are previews for each design that can be viewed in detail simply by dragging it up. The scroll bar makes it easy to walk through the designs we're interested in. The plot that we're looking at here is an isoplot with vectors. Any plot that you view and save can be used in the decision center. Here is the section plot we were looking at earlier. Viewports is another way of comparing the results in the graphics view. Once again, the designs can be dragged into each port. The legend and orientation remain in sync for each viewport, providing an apples-to-apples comparison. Let's, for example, change the maximum value in the legend for velocity. Again, that will update each of the viewports, as you can see here. Summary information can also be saved from the section planes or probe points for comparing maximum values. Taking a look at the values for pressure drop, we can see there are a couple of cage designs that are below our requirement of less than 2 psi. Design 5 is performing the best in this area. The XY plot that we viewed earlier can also be saved in the decision center so we can view and compare the results for all studies at the same time. This way we can view the results for pressure and velocity from the inlet to the outlet of the valve. Once again, the shape of the holes in the 5th cage design is clearly going to perform the best. It's not only going to help control the flow, but also reduce time and money on maintenance costs. And finally, all this information is automatically added to a report that can be shared with others. It comes with a cover page, table of contents, material information, boundary conditions, solver settings, and of course the results of all studies. Autodesk digital prototyping using Simulation CFD enabled us to choose the best design with no extra manufacturing costs. This also saves time, leaving room for product innovation.